Thanks, Lee and Sam, for that intro.
Welcome to BB8 101. I'm John.
I'm Andy.
And today we're going to go through the various options of what you choose when you're thinking about doing a BB8 robot. We'll go over them all.
We're going to start with spheres.
Then we're going to look at the choices of skins.
And then we're going to move on to all the different drive options that are out there.
And lastly, we're going to finish up with the future of BB8 building and some of the exciting options that are coming out from the community and are in development now.
Some of which look really good. I'm quite looking forward to the Von Jet hamster.
Yeah, especially paired with the new Dan Brune drive. So all of that's to come later, so stay tuned for that.
But first of all, we'll kick off with the spheres. So
when you're doing a BB8, there's quite a few choices to make. Do you want to go hamster? Do you want to go axle? The reasons for doing either are based on two types of droid.
I suppose the main reason would be cost. What's your budget going to be like? Do you have a few £1,000s to throw at this, or do you only have a couple of hundred? That would straight away determine which route you go down.
Yeah, and it helps your design ethos as well. Like, it may be that you want to do something completely custom. It might be you, due to limited funds, you decide to do something that's just a static with a wiggle head.
Using just a fiberglass ball.
Yeah. But we'll go over those options and why they're there just quickly. The axle drive is it's a representation of the stage droid that was rolled out at Star Wars Celebration Anaheim when we first saw BB-8 in real life. And then obviously you've got the ball hamster type, which is probably more true to what BB-8 should be, and it's purported to be in the film.
That's can roll in any direction at any point without.
But yeah, once you've made those decisions, that divides your options up with everything we're about to talk about.
Yes. I think it's fair to say that hamster is probably the cheapest to start out with. And then you start working into the axle drives. Probably starting with Joe's drive, I would have thought. And then working your way all the way through up to Carey. And then I'm not sure if there's anything beyond Carey on that point. But
the full Mark 1 copy that someone is working on is definitely pushing budget limits, I feel.
And a drive we're going to talk about later, which is Dan Brune's one, I would say probably sits comfortably in the middle. Straddles the point where it becomes a cheap hamster and expensive hamster and a cheap axle drive. I think that's probably he's going to be straddling that point.
And then there's some drives that are exciting and coming soon, but may actually be slightly more expensive than a Carey. We don't know yet because it's still in design, and they're on like revision 4 or something ridiculous.
But yeah, once you decided which you're going to do, if you're going to do hamster or axle, you basically then decide which type of sphere you're going to do. If you're going hamster, you have the choice of the T&M sphere, which is my current design, and upcoming you also have the Von Jet hamster. You could also make your own one out of polycarbonate. We won't be covering the polycarbonate one because that's pretty self-explanatory. It's just a polycarbonate sphere you shove the drive into and roll it around like a hamster in a ball. After that point, it's if you're going down to axle, you're a better place to talk about it more than me. But
yeah, so in axle spheres, you've got the Carey injection molded sphere, which is a 2-part sphere with that needs a separate set of skins. And then you've got the Von Jet, which is now up to V3, which is an all-in-one sphere that requires no extra skins panels because they're already built into into it. There is a 3D printed version of the Carey sphere as well, but we won't mention that today because its features are pretty much identical to the Carey injection molded one.
Okay, so I think we will dive right in and we'll start talking about spheres. We'll see you in a bit. This is the T&M hybrid sphere. It is actually a very clever design, especially for one of the first iterations of BB8 spheres. That's what a triangle looks like. It's, as you can see, it's just 3 separate pieces that are 3D printed, joined together with hex screws and a bolt. Sorry, a nut. This one's a bit loose because I've taken it off and replaced it with something I'll show you in a second. Triangles are similar. Circles are similar. 4 sections screwed together and then screwed to itself. I think this printed in one piece may also work better, but I think this design has been abandoned now. This is the design unless somebody wants to take it further. So I spin around. You can see why I dumped a triangle. I reprinted with this clever hatch design here, and you just twist lock, pull out, and then you can see inside. You supposedly you can see inside to get to fix stuff. It's still very tight. I think one of these would have been better personally, but in order to get into there, i.e. to get one of those off, you need to take off 4 triangles. Whereas here you just take off the 1 triangle, unscrew, you got access. Something to note with the club panels, as I said, they are strong, they are thick, they are strong, they are sturdy, providing you print them in one piece. I printed all mine in 2 pieces, because at the time I didn't know you could print the triangles in one piece, and I didn't have a printer big enough to print the circles in one piece. But as I said, yeah, that is pretty tough. It's just unfortunate that it also affects the magnetic strength. Possibly I could use stronger magnets. As I said, you've got the thickness of this. Where's the triangle? You've got the thickness of this, plus let's get a triangle. Plus the thickness of a triangle on top. You've got that much plastic preventing your the magnetic force between the head and the body magnetic mount. The original idea behind this was it would be either axle or hamster drive, but then not long after Carey released his sphere, which eliminated the need for this to be for axle. As it is with the hamster drive, theoretically I can drive in any direction I want. I'm not limited by that one axle, by that one direction of travel, and I don't need to lean to turn. I can just spin on the spot and go off in the new direction. For a static or wiggler, that'd be perfect. You could put a DMM, a BMM sort of on here on a stick as normal. Just put a little motor in there on some wheels to wobble it around, and then have a dome magnetic mount in the head, and then they say you've got yourself a wiggler. So I've undone all the screws around the circumference, and I knew that was going to happen, I still forgot. And now we've got access to the drive. Okay, so as you can see, that's my hamster drive. Let's get them out. Briefly put them over here. This is the inside of the sphere now. As you can see, it's fairly smooth. You could, so the recommendation is that you do coat the inside with resin or something else that smooths it, so you don't get the little bumps in between. You also need to tighten these as much as possible. This has flexed. They are starting to come apart, and they just need doing up again. You could also super glue the nut But you'll be able to see it. You could also super glue the nut to the end there so the screw goes through. You don't, because half the problem is when you try and put this screw in, you have to hold the screw while doing it up, and then the screw falls off or you miss a line. But once that's in, and it is strong, it does work, it does the job, and you can drive a hamster in it. Dave Alvarez and Dan Brune are both using these spheres. But yeah, they both have successfully used these spheres, both with the club panels and with the thin panels. Yeah, that's a T&M sphere.
So this is the Carey injection moulded sphere. It closely follows the Carey 3D printable inner sphere design. When it arrives as a lot of little panels, so from this line here over to there, those parts repeated to make the entire frame. In between there you have several cross brace members that go underneath the circle panels. This means if you were to remove a circle, you can just pull these bars out and gain access to the insides of your drive. Put them on again. And they're designed in such a way so they do slide a little bit. The idea being that your circle can get its position centered around the triangles that are going around it. That centering position can then be pinned in place by screwing in the triangles. One nice thing about this design is it's very lightweight, it's thin. Downside again can be cost. We need to get these from the US. There are some builders that occasionally do runs to get them from the US, from Carey imported. It can save you quite a bit of money. One thing that I really like about this design and why I did my first BB8 in a Carey sphere was you can quite readily just remove the drive just by separating these three sections. You loosen off 2 screws per quadrant there, and you can just pull it apart. They are braced using little 1-cent pieces that are just embedded in there and glued in, and then make sure I get it the right way because I've labelled them all. You just slot them all back together. Once you're done and your drive is in, your drive will connect via these hub points. So one hub point on the removable section and one on its opposite side there. Those holes are cut out to allow the speakers or transducers access to the outside. And yeah, all in all, a really good sphere. I've got the rest of all the cross brace bars there, and some are designed for specific points on the sphere. So there are some panels that have LEDs just underneath here, so there's a channeled out area for you to stick the LEDs, and the other ones have just got runs going in between them. Another feature there, you've got a run going through to allow for wiring to get around the sphere underneath the circles. Like I say, exceptionally good sphere. Downsides are cost. Go with this if you're looking for separate panels to go on top, and you want looking at an axle design drive, and you want something that is both lightweight and incredibly easy to use following on from that. Next up we have the Vonjet V3 files. The Vonjet utilises a much thicker frame, inner and outer sphere in one piece. So what you have is you have a very thick circle, but you don't have to pair an inner sphere to an outer sphere. The files are quite well designed. They use some aluminium bars with screw holes in to join the triangles together. They have ridged areas here that the circles lock into, and those circles lock in, once finished, they have attachable, some of them are screwed in, but the example I've got here is a triangle that allows for on this edge, it allows for a circle that is screw locked in, and it uses some power delivered wiring that comes out at the edge of the circles for the power delivery modules. The circles are pretty solid. They are designed to hold your sphere. Material wise, you have to be careful because you have to maintain strength and rigidity, because you don't want deformation due to the weight of your drive pulling your sphere down. But this is a really well designed system and fairly cheap to make and produce, because you're not buying an inner sphere and printing that, and you're not then printing panels on top. You are doing you know, your 6 circles and your however many triangles it is. I think it's 16. But they fit together really well. The gaps in them are very, the design gaps are they're quite thin, but they are deep, so your wheel shouldn't have any problems going over them. But again, an amazing design. I've not finished the Vonjet yet, but I've been so impressed, and we'll talk about future developments of the Vonjet going forward. The group are doing quite a bit. So as you saw there, we looked at the Vonjet sphere, and that had integrated skins panels. No need for a separate print. That's great, but some of the spheres that we've talked about need separate skins to go over the top of the spheres, and so we'll talk about them now. So with panels, first we have here the club spec panels. These are freely available on the BB8 forum. Club spec, there's a couple of varieties that use different screw mounts. Some allow for Allen bolts to go in, some allow for countersink. Myself, I use some special screws that are designed by Carey, and they are sort of an off-cut circle piece with a special screw-in tool. They can just be painted and they look flat like the sensors that are supposed to go there. But these panels are you know, about 6-7 mil thick. There's a ridge going around at the outer edge there. They come in one piece. You can get hold of two-piece. They come in two-piece. You can get hold of one-piece file versions as well. The LEDs, the holes are all built in. So advantage for this, these are tried, proven, tested. Circles, many builders have used them. There's a lot of people that know how to print, how to attach, what materials to use, what strength, what infill, what walls to use for each sort of printer. This is just one of the triangles. Again, I've tried to pull the one that shows the transducer mounted to it. That fits into the whole of my sphere. But again, a 2-part panel with a line going down the middle there, where I've bonded it together and then painted it. These files are, like I say, easy to get hold of, very tried and proven. They're a little bit thicker. The disadvantage to the thickness of these ones being your magnets that attach your head to the drive have a bit more distance to break through, whether you're using a T&M sphere, a Carey sphere, or any of the others, minus the Vonjet, because that has its own skins. That increased thickness means your head needs a bit more magnetic force to hold it in place. You also need to make sure all these ridges are smoothed a bit, so there's less jumping to allow the wheels to come off. So now we're looking at the Carey designed thin panels. These are designed to be printed using a durable but not too flexible material. These are extremely thin. If I grab one of the other panels, so this is the club spec panel, and it's about twice, if not more, thicker. than if it's about twice, but or if not more thick than the carry panel. The carry panel is designed only to print in one piece, I believe. They use some very interesting interlocking triangle pieces there, so you've got some rigid teeth that join together, and when on the sphere provide a very good kind of support to each other. But these, I mean, the triangle pieces all lay flat against the sphere. They're designed for the carry sphere primarily, but could be used on sort of a TNM. The other advantage with these files is Carey has designed a set that allow for a removable quadrant one that allows you to access a charging port. So he's designed a whole charging assembly that will go into this. Again, uses the standard sensor mount holes that you would see on the club ones, but all of the lines in both these and the circle part files are greatly reduced in depth. So this is thickness. This is to prevent the jumping that you'd see. Just like the club files, there is a lip that the triangles lock down upon, and that lip pulls the circle down and against the sphere. So it can still do the sliding that we described in sphere section, but it can be pinned down by these. The interlocking mechanism is superb on these. Will need a little bit of filing. They're, due to the extreme thinness of them, they're a lot quicker to print than the club spec ones, but you've got to make sure you get them right. And same with the circles, the inside needs to be sanded off. You'll get a lot of support material in the middle that you need to try and sand off and remove, because they're so thin they can't have as many layers that feel underneath them.
So that was skins, and as you can see, you've got plenty of choice, including the Von Jet, which gives you an all-in-one. And we're now going to talk about the drives. I'm going to start off with the hamster drive. This is the Dave Alvarez variant that I'm working on, which in turn is a variant of the Ken Gorby one. It's compatible with the TNM sphere, a polycarbonate sphere, and the upcoming Von Jet hamster. And then John will be talking about the Carey drive, which is compatible with pretty much any sphere on the market apart from a polycarbonate sphere, with a bit of work. And then we'll cut back to us and talk about Joe's drive, and we'll leave it from there. So, over to drives. Right, so now we have the drive out of the sphere. We can now see fully how it works. So as I mentioned before, this is my variation of a Ken Gorby, Dave Alvarez, Travis Wheeler drive. It's based very, very closely on Dave's drive, although I've had to make my own changes, like with the wheels here. Unlike Dave's, mine's running on a modified Shadow. So it's all Arduino based, which I just feel a bit more comfortable with an RC at the moment. That's not to say I won't swap this out to be RC. Dave's is RC, but they all run on the same principle. We've got a remote switch here, a bit like the Carey drive as well, also has a remote switch, connected to a power socket, a power switch there. So just spin it around and zoom in a bit. So there's a receiver and remote switch there. Yes, this is the battery input, and this is the output to the actual droid itself. If you're familiar with Shadow, then you have the saber tooth for the motors, the Arduino Mega with the host shield on top, which is the brains, and that's pretty much it. That's like the normal Shadow. Where I've modified it, I've now put a HCO5 connector which goes up to the dome, and that has a corresponding HCO5. So I tell it to play, I click a button on here, it will play a noise, send a signal up to the dome, play a noise. The dome drive on the Shadow is a siren. That's now been replaced with, zoom out again, that's been replaced with a continuous servo here, and then fuse box as well. The motors come from Servo City, as does all the metalwork. That's all Actobiotics, and we have 25 kilo servos to pull the head around, because obviously when you sit the magnetic force of the head on top, it's going to be a lot stronger. These are the drive wheels here. These are just stabilising wheels to keep it stable in the ball. I have power, so power on. Servos are told to centre. And we now turn the PlayStation controller on. There we go, it's connected. So for some reason only one motor is working, so I probably disconnected the motor by accident when I took it out of the ball. So let me just spin it around. So as you can see, I push forward, the motor gets moving, back, the motor goes the other way. You can see also that I've written into the code that the head will tilt forward or backwards in the direction of travel. It tries to stay level. It doesn't work quite that well. And then left and right, as you'd expect. For me to use the dome, I've got to push the top button, and that just moves the head on its own. So in my case, so that one is up and down, and that one left and right, both at the same time, turns the head. There we go, and that will recenter it. As I said, it's running on Bluetooth, so you've got the initial Bluetooth connection from here onto here, using two 12 volt 9 amp hour batteries to give me 18 amp hours, with a step down converter for the Arduino. All this here, let me just zoom in again. All this here is the start of me trying to put in the IMU. In fact, you can just about see the IMU there. So on its own, without using the IMU, a lot of the stabilisation comes from its weight, and a lot of the weight is from this nice dumbbell weight here on the bottom. As I said, these are here just to stop it rolling too much in the ball, sort of rolling too far up that it almost tips back on itself. The head is moving on a gimbal. There we go, you can see it here. So there's a 3D printed gimbal here with a couple of bearings in, with the bar going through, and then two smaller bars either side, and then that gives you, you can see that gives you the tilt on the left and forward and back and left and right. And that's really what is at heart, just 3 servos and a couple of motors. You could quite easily RC it, but overall I'm quite happy with how the hamster drive works. It's one way of doing BB8. This means you can turn on the spot and go off in a different direction. It gives you that true feeling of the fact that the ball can go anywhere. Yeah, I think that's it on this drive.
This is the carry drive. As you can see, it's a little bit different to the hamster. It's an axle type drive, as we've spoken. One of its main advantages is it has a very good range of head motion, as most of the drive is below the axle. It means you can actually lean the head over and forward and backwards a lot more than you can with some of the drives that have got sort of bits positioned around here. Mine differs slightly in that it's going through an upgrade, so all these spare cables you see off the other side are due to me having a more wire slip ring, because I'm going to be routing USB connectivity through to the external of the sphere. So it's an Xbox controlled drive. Has a wireless FIMCO switch that we use to enable it and disable it in an emergency. Has an IMU integration, it has audio, it has quite powerful speakers. You can opt to go with the transducers right up against the panels, so you can get quite a bit of audio out of both sides of the sphere. The advantages on this, a lot of the parts are either 3D printed or fairly readily available. There are a few exceptions in some very custom parts that are designed, such as the gearing that goes around to spin the counterweight at the bottom, and the arm that you'll see at the front here that is used to the arm that you'll see here, which is used to tilt this up and down. The gearbox, I think it's going through a bit of a redesign at the moment for that weight, because it's not as readily available, but the group's been supporting that change, and Kerry has done some very good redesigns. There are some custom electronics parts available through Stefan, but I think that's just to tidy up the functionality. Everything could be manually routed or broken out if you required it. Again, Bluetooth, so you're talking about the limitation of range with Bluetooth and interference, and the popularity of using Xbox controllers. Troubleshooting with this drive is exceptionally easy. There's quite a large group of builders out there, all willing to help. Kerry and Stefan themselves have been incredibly helpful with me building mine. The ease of the prints, they're very well designed, and most print with little to no support. There is a small centerpiece that you need to make sure you print out of very hard wiring material. All the weight is centered on that. The bottom weights vary, something to look out for balancing your drive. Feature wise, it has a lot through the controller. There's 3 speeds. There's a slow drive speed, so I'll just enable the drive there. So that is slow. And then there's a faster drive speed. And a 3rd speed, but that will just end up with these wires hitting me in the face, so we won't have that. I'll just turn that off for now. That's about all there is to say. I think the only worrying part for availability's sake, like I say, is this gearbox and the Mega ADK that's used because you require an extra USB port for the Bluetooth module, is out of production now, but I think you could mirror that with just using a USB hat. And that's the Kerry drive.
Okay, we're now going to talk about Joe's drive. This is going to be slightly more awkward for us because neither of us actually have one, but we have the Fusion files in front of us and we're going to discuss them as we go. So Joe's blurb about the drive is this: a cost-efficient and superb performing internal drive mechanism for a ball-shaped droid. It may not win a beauty contest and it doesn't look like it belongs on the stage, but it's easy to build using off-the-shelf parts, which was my goal. And he's pretty much done that. The Joe's drive is 3D printed with parts you can just go and buy off the shelf, and I assume it probably means off the shelf in America, which make it a little harder for us to get stuff in the UK. But as you can see, on the face of it, it looks very similar to a Kerry drive with the axles. We also have the mast as well, which is more reminiscent of a hamster drive, with the 2 servos just in front of the mast, and a precursor to a Kerry dome body magnetic mount across the top. John, if you'd like to just spin it around slightly so we're looking side on. That's it, thank you. So as you can see from this side, we have the battery packs, which are on opposite sides of the drive rather than at the bottom. This is due to just keep the weight as equal as possible. But as you can see, it has a continuous servo in the head, like most droids do. We have the counterbalance at the bottom on a lazy solution, and then all the drive mechanisms. All the drive electronics sit on top, just above the batteries. Like the Carrier, you bolt it directly to a sphere. I don't believe this one has transducers in it, does it?
No, but there is a transducer version for the hubs, so
Right.
because that's going up against the sphere anyway. So
Yeah.
speakers and transducers tend to go in that part of an axle drive anyway.
Yeah. So, like a hamster drive, this one has limited range of motion in the head, as John alluded to earlier. Unlike the Carry-On, which kind of gives you almost like a 360 roll around the top of the head, the top of the body. This one will allow you to spin on the spot, and to turn it leans just like a Carry drive does. Something we should point out: this is version 4.
3. This is Mark 3.
Mark 3. And as of filming, we found out that he's actually designing a new drive system, of which we have no other details other than that. It's something he posted on the Facebook group.
The early photos do show that it seems to be a cleaner design with a lot more open space. And with batteries mounted seemingly at the bottom to put most of the weight at the bottom as well.
Yeah, which follows pretty much what all the other Droid designs have done since then. Joe's relies on lead shot bin in the bottom, much like the Carrier, I suppose. As we said, this is mostly a 3D printed droid, and uses off-the-shelf parts for the mechanical components.
And it's worth saying it also has a large community of builders as well, and Joe's documentation is pretty good. For the Mark II, at least, I think the Mark III, there's you basically go so far down the instructions and then switch to a Mark III set. So yeah, very good. Uses dual motors to drive the axle. These are mounted in the bottom. That's about it, really. It's a very capable drive, and I will be building one soon. I just haven't yet. It's sad to have a sphere with nothing to push it around.
Could always just put a cat in there.
Yeah.
Yeah, that is the Joe's drive.
As you can see from all those drive options there, there's a lot to consider when looking at drive. We have produced a chart, however, if you want a quick reference to look at.
Yeah, so it's nicely color coded. It just basically says, well, here's your 3 drive options. There are more drives available. Here's your 3 drive options, and here's the pros and cons for them. So in the case of the Alvarez Gorby drive, it's probably the cheapest and widely available parts, but its documentation and support is pretty non-existent, really.
And the movement's good on it, but like you said, the 2-axis movement limitation and the mass type dome movement can be more limited than, say, the carry servo on a stick connected to servos method.
Yeah.
But as we mentioned there, that the carry is probably the pricier of the 3 we've talked about, but is and there are some custom parts there, but it does have a really good range of motion, and it has an incredible community to help build it.
Yeah, I think it's fair to say with the carry though, anything you order, it's coming from America. Expect it to take a while. Expect to get hit with a customs charge afterwards. When it does turn up.
Yeah, and then they're done as runs that carry, and for the electronics kit, Stefan do runs every now and then, so they run a few times a year. And then Joe's drive, middle ground in cost.
Yeah.
all the parts are either widely available or 3D printed. A fairly good community, and it's got the similar sort of capabilities to the Carry Drive, but again with that mass type servos with sticks, head movement technique, you don't quite get the total range that you would with the Carry.
No, you're pretty much limited to forward and back, left and right. It's very hard to sort of go off to the side. So
yeah. So they're the current drives available. Now let's talk about some of the future of BB8 and the developments coming out of the community that we're very excited about.
Yeah, and we're even taking part in some place.
Yeah, we've got new drives being designed from the likes of Dan Brune and an extension of the Carey drive, and then the Vonjet, Andy.
Yes. So this is taking the original Vonjet idea and effectively smoothing out the inside and allowing you to put a hamster drive in it and giving you the best of both worlds. A single panel, single skinned droid, and with the ease of the Vonjet. So as you can see here, this is a modified remote control for the Carey RC. They've replaced the normal axis control sticks with 3-axis gimbals, and we just watch Stefan turn it on. Get a nice BB8 logo. Here you can see all the different channels that the drive is using. So the twist, this is the head twist, I believe, and then forward and back, left and right. And then that's the kill switch, so it kills the drive off. And then he's going to choose a different screen. So as you can see, you've got hollows enabled there, but he's pushing the momentary buttons here. And each one sets the channel off to different directions. So we presume each one is setting off a sound. And then that's the drive enabled. Or the gyro.
The other thing there is there was a hollow enable button, so like re-enable the hollow if needed as well.
Yeah.
But looking at that drive, you're going to have to modify remotes as well as build a drive system at the same time.
But when you've got Matt Hobbs involved, I imagine there will be proper instructions involved in there, and it'll be worked out properly.
As you can see here, this is the kill switch that we mentioned. This is used to stop the droid when loss of signal occurs or if there's a dangerous situation. As you can see here, here's a video of the drive in action, piloted by Matt Hobbs, a member of the community. Special thanks to Stefan Beaulieu for this footage. Stefan does most of the electronics and software work in conjunction with the other designers.
Must make it drive very well, doesn't it?
Yeah, it's a very stable drive, the Carey drive, with very good use of the IMU.
Yeah. The head's, although I must admit, the head's not moving as much as I thought it would. I wonder if that's just because they're testing it and they don't want to go nuts.
Yeah, possibly. There is a very wide range of motion on that.
And there we go. That is the Carey RC drive in action.
Coming soon.
Coming soon to a BB8 forum near you. So here we can see the Vonjet hamster that's being built by Dan Brune. All the pieces have been printed out using a 0.6 nozzle. As you can see, it's actually very similar to the Vonjet normal. It's just a very smooth inside. So if John will go to the next picture. And then here you can see the hamster sphere in comparison to the T&M. As you can see, Dan's using the Carey thin panels on his T&M. And you can just see a small part of his 3D printed drive in there. Yeah, so as you can see with the hatch design, it's using the circle rather than the triangle. It gives you a lot more space to get into, get your hand in, and as you'll be able to get your hand in from two sides, you'll be able to access the drive a lot easier. It also means you don't have to take off as many panels if you want to get more access into the spheres compared to T&M.
So now I'm going to do a little demo of the drive and powering it up and its functionality. As you can see, I'm using a Spectrum DX9 with modified sticks, which are used for head rotation. And to power this guy up, I hit power number 1, and that will power up the receiver, which gives me functionality over the head only. The drive is not working at this time, so if I want to use this in static mode, is what I call it, I have full functionality of the head without having to worry about accidentally hitting the drives and having the guy take off. And another nice feature is I have a 360-degree self-centering servo. And the nice thing about this is the head will always be pointed forward at dead stick, so when it returns, forward is always going to be forward. You know the direction that the drive is going to be going. And this really makes puppeteering easy without having to give up any rotation on the head. And I can actually turn this all the way up, I believe, to 720 degrees. So if I wanted it to turn 2 full turns and then back, I have the ability to do that as well. So now to power up the drives, I have a separate power switch, and then I'm using a remote so I can turn it on and off from outside the dome. It also works as my emergency kill. As you can hear, the fans are a little bit loud, so I'm going to unplug those real quick. Those are the cooling fans for the motors, which helps keep this guy nice and cool. And now I have forward, reverse, left, and right. So that's it. That's a summary of the drive. Still have to get the stabilization figured out, and still tweaking on some of the speeds on the servos. I'll be hooking it up and slowing some things down and smoothing some things out, and hoping to get it in the drive real soon. So there you have it. That's the DB8 V2.
So as you can see, there are plenty of options when it comes to building the BB8. Like with any droid building, it depends on your budget. You can make it nice and cheap and it'll roll around, or you can spend as much money as you want and it'll have all the bells and whistles. Though with BB8 at the moment, there aren't that many bells and whistles.
And it's all a personal decision for you, the builder, to take. So you assess what you want and what you can afford.
Confidence as well. I mean, do you feel confident is assembling a whole carry drive? I mean, looking at John's, it is incredibly complicated when you just look at the thing for the first time. Or do you? But then it's well documented. It's got plenty of documentation. It knows what it's doing.
And with a big community to support you as well. So
yeah, or as a hamster drive, it's fairly easy to put together, but you're pretty much on your own at the moment. There's not much in the way of a community to help put it together, mainly because I think builders as a whole prefer the axle drive.
Yeah, but like and as we saw earlier, the future is bright, especially with some of the exciting developments coming out of the community in both hamster and axle drives.
Yeah, I can see I can see the Von Jet hamster and Dan Brune's drive kickstarting that again, and people going, oh, actually, it can work, it can look good, it can work well. And I think the most important thing is there's going to be documentation to go with it as well.
Yeah.
Dan,
like we say, some very
documentation, Dan.
So with that, thank you everyone for your time, and we'll go back to Sam and Lee in the studio.
Well, while we let Lee quickly get himself back together, we'll just fill in a gap or two. Thank you very much for joining us. I hope you've been some help.
And reach out to the community, reach out to all of us. We're all here to help.
Yeah, we're all. There's no such thing as a stupid question. We're all here. We all started at the beginning once.
I think we're good now.
Are we? Excellent. And now back to Sam and Lee.